Okay, so in Unit 8, we are going into sequences. You may remember them a little bit from 8th grade, but we didn't do that much of them. So a sequence is defined as a function. Everything in Algebra 2 is a function. That's why it's called a family of functions. And it has a domain, and the domain are the positive integers. 1, 2, 3, blah, 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 4, 5, 6, familiar. So what we have here is we have a function. It happens to be called function A. Sorry, you hear the printer in the background. Now, what is function A? Function A says we double whatever we put in for it and subtract 1. So if we were to write the first 3 terms of this is what it would look like. Remember, the domain are positive integers. So the first thing I'm going to do is, in for A, I'm going to put a 1 in every time I see an N. That's how I got this. So the first term of function A is a 1. And then what I can do is I can go on for as long as I want. If I want to find the second term, I put a 2 in. And by doing the math, I see the second term of function A is a 3. And I could keep going and going and going. I have one more right here. If I put a 3 in, 2 times 3 is 6. The third term of function A is a 5. Now sometimes I like to write it out, since the word sequence to me means to go in order. I like to write it out like this. And down below I'll say in the first spot of function A is the number 1. In the second spot of function A is the number 3. In the third spot of function A is the number 5. And since this was an easy function, we could see that we could figure out our next terms quite easily, because simply we were doing the odd numbers. Now what we just did was called an explicit function. It means we could get right to whatever term we were looking for. So say, for example, I asked you to find the 7th term. Well, you wouldn't have to know anything. I just know I put a 7 in for N, and I double 7 and subtract 1. Oh, that's number 13. But now we have also what we have. We have recursive sequences. And recursive means we have to do an operation on the previous term. So down here we have function B. And what does this all mean? Well, this is telling me I'm starting with my first term as the number 7. And now I got some funky writing right here, B sub n and B sub n minus 1. Well, I think you remember from 8th grade, because I know we did this in 8th grade, I like to call this B sub n is some term, right? We don't know what n is. And then n minus 1 would be the term before n, right? And if I gave you B sub n plus 1, that would be the term after n. All right, so if I had to now find the first 5 terms here, what would I do? Well, I'm going to clean this up so I can read this now. And this is what it's saying. To find some term, we go to the term before it and add 4. All right, so if I needed to find b sub 2, I go to the term before it and add 4. And then we can keep going. To find the next term, we add 4 onto this. And to find the next term, we add 4 onto that. And to find the next term, we add 4 onto that. This is a recursive sequence because I had to recur to the term before it. And it's arithmetic because arithmetic means to add a constant. So I was continually adding 4. Now, the problem with recursive is if I asked you to find b sub 19, or the 19th term of b, I couldn't do it. I'd have to go all the way out and know what the term 18 is to find 19. But you may be saying, but I can see the pattern, and you're right. We will learn how to write an explicit sequence function formula so that I don't need to be recursive, but that's another day. All right, so example 2. Can we write a rule? That's another word for a function for the Fibonacci sequence. Well, yes, we can. Now, when we write a rule for a recursive, we must always start off with the first term being defined. We have to know where to start because we have to recur back to it to get the next term. First term must, whoops, I forgot the M there, be defined. Now, for the Fibonacci sequence, the second term is also defined because the second term, and this is rare, this rarely happens. So notice what it's saying. I didn't say a sub n. I could have, but instead I wrote it a parentheses n. They mean the same thing. It's just what notation you like. This is saying to find this term, we must go to the term before it. All right, so if I'm going to find term 3, I'm going to the term before it, which is 1, and adding on to it, well, the term 2 places before it. Oh, 2 places before this one would be 1. So the third term of the Fibonacci sequence is 2. Great. To find the fourth term, I go to the term before it, right? 4 minus 1 is 3, and add on the term 2 before it, because if I put a 4 in for n, 4 minus 2 is 2. So the fourth term is a sub 3, which is 2, plus a sub 2, which is 1. So that is 3. And the final one we'll look at is again a recursive formula. And can we find the next 3 terms here? Well, since it's recursive, we have to define the first term. The first term of sequence t is 3 radical 2. Well, what am I doing? This is saying to find a term, we go to the term before it and multiply it by radical 2. Okay. To find this term, we go to the term before it and multiply it by radical 2. Radical 2 times radical 2 is 2. 2 times 3, 6. All right, go to the term before it, multiply it by radical 2. No. 6 radical 2. Go to the term before it, multiply it by radical 2. I think you get the idea. 2 times 6 is 12. And then this would be 12 radical 2. All right, actually I had one more. Given the first term is 6 and the fourth term is 18, and they're numbers of an arithmetic sequence. All right, so as soon as I say sequence, what I like to do is draw myself some slots. And I'm going to draw 4 slots because they gave me 4 terms. They told me the first term is a 6, and they told me the fourth term is an 18. Well, I don't know what these terms are in between, but they gave me enough clues to figure them out. They told me it's an arithmetic sequence, which means I'm adding on the same amount every single time, and that gets me to 18. In other words, what I did was I started with the number 6, and I added on 1, 2, 3 differences. Right? I added on something here to get me to the second term. Then I added on something there to get me to the third term. And then I added on something there to get to my fourth term. So 6 plus 3 times some difference got me to 18. So now I know my difference is 4, and I can just say, well, this must have been 10, this must have been 14, and I could keep going to get to the value of 20. Now we are going to learn an explicit way to get there much quicker. And basically you can kind of see it from right here. What I did was I started with the first term, and to get to the fourth term I added on 3 differences, 1 less than the term I was looking for. Because I already had the first term accounted for, and then in the spaces in between is always 1 less than the term I'm looking for. So if I just take my first term, and I'm going to add on differences, in fact, 1 less than the term I'm looking for. We just generated an explicit formula. So to find the 20th term, I start with the first term, which is 6, and add on 4 19 times. 4 times 19 is 76, plus 6. So the 20th term must be the number 82.